This is number 3 from the 2012 exam. Okay, so we are given the graph of f, which is a continuous function defined on this interval. And it consists of 3 line segments. We see that 1, 2, and 3, and then a semicircle centered at the origin. And they give us the relationship between g and f. So what this means is that f is actually the derivative of g, which is a good thing to keep in mind. We want to remember when we're looking at this graph that we're looking at the derivative of g. So for part A, we need to find g of 2. So g of 2 is the integral from 1 to 2 of f. So if we look at f, we're going from 1 to 2, and that's this little triangle right here. So we can find the area of that triangle, but the triangle is located underneath the x-axis, so we have to negate that. So we've got negative 1/2, and the base is 1. This is 1, and this dimension here is 1/2. So g of 2 is equal to negative 1/4. Now we do the same, but for g of negative 2. So we're going from 1 to negative 2. And I don't really like when my limits are out of order, so I'm going to change this around. So now we've got negative. We're going from negative 2 to 1. So negative 2 is here, and then up to 1. So we need to find the area of this triangle and then subtract out the area of this semicircle here. So this triangle has a base of 1 and a height of 3. So it's 1/2, a base of 1, a height of 3, minus the area of the semicircle, which would be 1/2 pi times r squared, and the radius is just 1. So that turns out to be negative 3 over 2 minus pi over 2. Okay, part B. So we have to find g prime of negative 3 and g double prime of negative 3, or state that it doesn't exist. Okay, so part B, g prime of negative 3 would have to be equal to f of negative 3, since the derivative of g is equal to f. And f of negative 3, here's the graph of f, here's negative 3. F of negative 3 should be equal to 2. And now on to g double prime of negative 3, which would be f prime of negative 3. So we're looking at the slope when x is equal to negative 3. So the slope of this line we can calculate by finding the change in y over the change in x. So 3 minus 1 over negative 2 minus negative 4. So we get 2 over 2, which is 1. Okay, part C, we are looking for where g has a horizontal tangent line. So g will have a horizontal tangent line when g prime is equal to 0. So again, here's our graph of f, which is g prime, and g prime is equal to 0 at plus or minus 1. So let's first write that down. So at x equals plus or minus 1. So our next job is for each of these points, so for plus or minus 1, we have to decide whether G has a relative minimum, relative maximum, or neither. So if we first take a look at x equals -1. Here's x equals -1. Notice that we have a sign change, that G prime changes from positive to negative. When the derivative changes from positive to negative, we know that we have a local maximum. So let's write that. G has a relative maximum at x equals -1 because G prime changes from Okay, now we look at x equals +1, which is right here, and notice we don't have a sign change. The derivative remains negative, so we don't have a local min or a local max at x equals 1. So G does not have a local minimum local maximum at x equals 1. Okay, last part, part D. So on our interval from -4 to 3, find where the graph of G has a point of inflection. Well, the point of inflection is going to be where G double prime changes sign, and G double prime is F prime. So we want to know where F prime changes sign. So F prime changes sign where F either goes from increasing to decreasing or from decreasing to increasing. And that seems to happen at x equals -2 because F changes from increasing to decreasing. Then also at x equals 0, F changes from decreasing to increasing, and then one more time at x equals 1, F changes from increasing to decreasing. So we've got -2, 0, and +1. And that is because G double prime, which is F prime, changes sign at these three places. As an alternative, you could have said because F changes from increasing to decreasing or decreasing to increasing. And that is it for this question.